Hello students, we already discussed about diffraction. The finite resolution of our eye or of optical instruments such as telescope or microscope is limited due to the phenomena of diffraction. Now we will see what is the limit of resolution of these optical instruments and then the resolving power of the optical instruments. Next topic is resolving power. What is meant by resolving power? See here two lines are here. You can see these two lines separate. But I will tell you, here also I made two lines. But you cannot see that. But if you observe it by using a microscope, you can see two lines here. This is the resolving power. Our eye, the resolving power is less as compared to the other optical instrument. So what is resolving power? Resolving power is the ability of an optical instrument to produce two distinct images of two objects which are very close to each other. Usual case, when you are seeing this with our naked eye, we cannot distinguish two lines here because the images of one line and the images of other line superimpose each other. But when you see with any instrument, you can see it separate. So the resolving power of that instrument is more than our eye. So if the points are very close to each other, then also you can see it separate. That means that instrument's resolving power is more. So we can say that resolving power is inversely proportional to limit of resolution. So what is limit of resolution? I told you the minimum distance of separation between two points so that they can be seen as separate by the optical instrument is known as limit of resolution. If an instrument can see object very close to each other, that means its limit of resolution is very less. Then also we can see it separate. That means its resolving power is high. So we can say that resolving power is the reciprocal of limit of resolution. This chapter we have to discuss the resolving power of telescope and microscope. Next we are going to discuss resolving power of telescope. Here 2D is the aperture of the objective lens and theta is the limit of resolution. So we can see that theta is equal to 1.22 lambda by 2D. This 1.22 is a constant. So what is resolving power? Resolving power is the reciprocal of the limit of resolution. So we got 2D upon 1.22 lambda. Actually in examination questions can come. What happened to the resolving power if the diameter of the objective lens increases? Diameter of the objective lens means aperture only. That is 2D increases. So resolving power is directly proportional to diameter or aperture. So resolving power increases. Then it is inversely proportional to wavelength. So as the wavelength decreases, resolving power increases. Limit of resolution and resolving power of compound microscope. Object is placed here. This is the objective. The cone of light coming from the object incident on the objective. Half of the cone of light coming from the object, that is theta. Lambda is the wavelength of light. Then mu is the refractive index of the medium between object and objective. You know that when we are using compound microscope, we used to mount the object in glycerin and keep in between the slides. So here also we are doing the same only. Now the resolving power is inversely proportional to limit of resolution. What is limit of resolution? It is equal to lambda by 2 mu sine theta. Then resolving power is 2 mu sine theta by lambda. 2 mu sine theta is called numerical aperture. So resolving power depends upon the refractive index of the medium, then the wavelength of light. You know that electron microscope is more powerful than ordinary microscope. Why? Because the wavelength of a wave associated with the electron is having less wavelength as compared to ordinary light. As the wavelength decreases, the resolving power increases. To increase the resolving power, we can increase the refractive index, but we have to increase the refractive index up to a limit. The refractive index of the medium should be less than the refractive index of the lens. If the refractive index of the medium is greater than the refractive index of the lens, what happened? The light will pass from denser to rarer medium. So no refraction will take place.